In this video, we're going to talk about similarity in right triangles. Our main goal is to determine unknown values using the relationship between different parts of a right triangle that has an altitude drawn in it. So, our first example, we are to look for the value of x. So, as you can see, we have triangle DEG with a right angle EDG and an altitude of segment FD. So if we're going to solve for x, we're going to use the formula in getting the altitude. And to get the altitude, we're going to get the square root of the product of the two segments on the hypotenuse. So those two segments are segment EF and segment FG. So to get x, we simply substitute the measurement of EF and FG. So, 7 times 9, that's 63, and the square root of 63 is 3 square root of 7. So, that's the value of x, or the value of the altitude FD. Next, in this case, we are to look for the values of x and y. So, as you can see on the figure, we have triangle RST with right angle RST and segment SB is the altitude to the hypotenuse. So, we're going to look for the measurement of this leg and this leg. So, let's try to solve first the leg X. To solve for leg X, so again, we're going to follow the formula. So, in getting the leg, you're going to get the square root of the product of the hypotenuse and the segment adjacent to leg X. And that segment adjacent to leg X is VT. So, if we're going to substitute the given, the measurement of the hypotenuse is 20 and side VT is 4. So, if we're going to multiply that square root of 80, and if we're going to simplify, that is 4 square root of 5. Next, to solve for y, the formula in solving for y is the square root of the product of the hypotenuse times the segment adjacent to leg y, and that leg is RV. So if VT is 4, what is the measurement of RV? Very good. That's 16. So if we're going to multiply 16 and 20, the answer is 320. And if we're going to simplify, that is 8 square root of 5.